Afternoon or good evening, grade 9s, depending on which time you are watching this video. I hope you're all doing well. This is just a short video of an assessment that we did, a formal assessment. It's for grade 9 geometry. And what it was about is all the types of geometry except for similarities. So that's the only thing we didn't get to. So it's geometry of straight lines, the geometry of parallel lines. We've got triangles, the geometry of triangles, and then the only thing with that as well was congruency. Okay, but I have made a video on all the types of congruency and similarity questions that you can get, where I sort of summarized similarity and congruency. You can look out for that. It's for grade 8s and 9, so maybe a little bit harder for grade 8s, but well on the grade 9 level. And yeah, this is the test that we wrote. So I'd like to go through this with you just for step by step, so that you can also have a look at what types of questions you can get to do with geometry. Okay. So with this one, just an easy question to start off with. Name the type of quadrilateral and list 2 properties that you know of this quadrilateral. Okay, so you have to know the properties. It's very important because you need to apply it in grade 9 and further on as well. So best that you just start knowing it. It's a once off and then you've got it. Okay, so this one here is a parallelogram. A shortened way is that you can also say it's a parm for parallelogram. And the properties, 2 properties that are easy. Opposite sides are parallel and opposite sides are equal. Okay, this one over here is a rhombus, or otherwise known as the drunk square, and that is all sides are equal and the opposite angles are equal. Okay, just 2 of those. This one over here is a kite, and it's got adjacent sides that are equal, and then 1 pair of opposite angles are equal. Okay, easy peasy. Okay, then moving on, question 2, they say to you, study the following 2 triangles given. A, B, C, D are all points along the circumference of the circle, and very important, A is given as the center of the circle. So whenever they give you center of circle and it's to do with congruency, then you must remember, you must look out for the radii. Okay, so over here, do you know that AE will be equal to AC, will be equal to AB, will be equal to AD? Why? Because they are all radii. Okay, so let's quickly have a look. Which ones should be equal to each other? AB should be equal to AE. Let's just see if it matches up. AE, yes. So we're going to start by that, saying that AB is equal to AE, and that is radii. Okay, then the next one, BA or AB will be equal to AE. So AB will be equal to sorry, I've just said that. Sorry. So we did AB is equal to AE, then DA. Sorry, so DA, let's erase that. So DA. So AD should match up with AC over there. So AC is equal to AD, and that's also because of radii. Okay, so just remember, we need to list 1, 2, 3 things that are the same. Then we're going to say thus triangle ABC is congruent to triangle AED, and our reason. Okay, so that will always be for 4 marks. Like it is indicated there, 1, 2, 3, and then the 4th one for your reason. Okay, let's continue. Then the 3rd one, can you see that A1 is equal to A2 because of vertically opposite angles? Okay, and then we've got, let me just highlight it with another color, we've got a side, an angle, and a side. And very important when using side angle side, the angle must be wedged between the two sides that are being used as well. Okay, so your reason is side angle side. Okay, I hope that makes sense. Then PQST is a parallelogram. So very important. What do we know of a parallelogram? So just note the blue things I am adding in. We know that the opposite sides are equal. Okay, we also know that the opposite sides are parallel to each other. Is there anything else we need to note yet? Okay, let's stop with that. Now they say to show that triangle PQR is parallel to STU. Okay, now already I've got parallel sides. I've got one side that is given to me that they are equal. It's always easier to start off with those. And then we've got another side that is equal because of the opposite sides of a palm that are equal. And then, but they also tell me that PRSU is a rectangle. And what do we know about a rectangle? Is that also the opposite sides are equal. Okay, so there we've got to prove congruency, so that's what they're asking, we can use side, 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 because that is a way of proving congruency. There's in the SAS, in the SAA plane, right angle hypotenuse side. Okay, so we need to note 1, 2, 3 things, and then we can say thus triangle PQR is congruent to triangle STU. Please keep with that order, it's very, very important. And then we need to note our reason, which we already know now is going to be side, side, side. Okay, so now we just need to go and list everything that we've known. Let's start with the one that was given to us. QR is equal to UT. So QR, which is over here, should be equal to TU. So QR is equal to TU, because it was given. How easy is that? Okay, now let's do this side over here, PQ. So PQ is the first and the second should be equal to ST. So PQ is equal to ST. And now the reason is the opposite sides, and that was of a palm, are equal. Okay, and then the third one is this PR. So PR, first and last. PR is equal to SU, first and last, because opposite sides of a square, because sorry, not a square, they told me it's a rectangle, sorry, of a rectangle are equal. Okay, that's easy peasy mark. So please, people, whenever they give you a write-up, don't just ignore it. Very important. The information there that's given is a guide as to what to do, as to how to use it. Okay, so very important to know your properties of the quadrilaterals. Okay, let's have a look here. Study the following diagram and answer the questions that follow. Calculate the value of x. Okay, hopefully you can see in this triangle, I only have one variable missing, which is an x. So I can go and add all of them together. And I know that it must give me 180 because of interior angles of a triangle. So 10 plus 3 is 13, 14, 15x plus 10 plus 20 is 30. Is equal to 150 if I deduct it on the other side. So x is equal to 10 degrees. Okay, now they say to calculate the length of EC. So let me just clear up here. And EC is over here. We know that EC is equal to CD. That has been given. But now, how can I work out EC? The only measurement that I was given is here, which is 13 centimeters. So perhaps maybe if I go and replace the x value in that angle and the x value in that angle, it will perhaps give me, can you see, an isosceles triangle there as well. And that is because of opposite sides of equal angles are the same. Okay, I'm going to get it right now. So angles opposite equal sides, or opposite sides to equal angles. Okay, so let me go and replace that. Let me just clear up here so that we can see those values nicely. Okay, so we're going to replace for 3 times 10 plus 10 gives you 40 degrees, and 2 times 10 plus 20 gives you also 40 degrees. So angle B, and we can call it B1 over there, just to make sure they know which one we refer to, is equal to C2, which is equal to 40 degrees. So thus EB is equal to EC is equal to 13 centimeters. So can you see it is an isosceles triangle? And this is the only one where you can't use it's an isosceles triangle. So because we've got the two angles that's the same, means that the two sides over there is also the same. So the correct reason is angles opposite equal sides, but then you can also use opposite sides. Let me just quickly go there. Opposite sides. Sorry, it's a different type of, let me just quickly think of it. Opposite sides to equal angles. Okay, but the other one that we normally use is angles opposite equal sides, and then equal sides to opposite angles. It's either opposite sides to equal angles or angles opposite equal sides. So that one is when we've got, this is given that those two will be the same, but then inversely, if we get the two angles the same, we know that the two sides there will also be the same. Okay, and then they ask you for the value of y, which is over here, but because we can see that this is an isosceles triangle, we know that this angle is going to be equal to that angle. Okay, so we can go and work out C1 if you don't want to use exterior angles of a triangle, or we can just use exterior immediately. That's what we would like for you to see. So can you see is a triangle with one leg being extended? Okay, so this side will be equal to that angle over here plus that angle over there. Okay, so E1 plus y is equal to this 2x, we can call it C2, is equal to C2 because of exterior angles of a triangle. Okay, and we know that C2, we said here, is 40 degrees. But now, before we say that, we can say that D is equal to E1. Angle D is equal to E1 because of, or you can say is equal to Y if you want. D is equal to E1, or you could have referred to it as Y is equal to E1. And that is because of angles opposite equal sides. So thus, and then immediately, you can go and work it out if you want. Y plus Y, should equal to 40 degrees. So 2y is equal to 40 degrees, thus y is equal to 20 degrees. Okay, but very important, you had to have exterior angles of a triangle and then angles opposite equal sides. You could have worked out that this one is 140 because of angles on a straight line, and then also E1 is equal to Y because of angles opposite equal sides, and then you can say E1 plus C1 plus Y is equal to 180 because of interior angles of a triangle. So then those two are the same, so Y plus 140 gives you 180, and then so 2Y is equal to 40, thus Y is 20. Okay, this one is just a little bit faster. So if you can use your exterior angles of a triangle, that's wonderful. But if you can't, you can take a longer way to get there as long as you note all the statements. Okay, sorry, statements and reasons. Okay, question 4. In the diagram, BCFG is a parallelogram. BCFG is a parallelogram. So what do we know about a parallelogram? We know that their opposite sides are parallel. And AC is parallel to GE. Oh, they've even given that. And angle A is equal to angle C, which is 55 degrees. Calculate with reasons the sizes of the unknown angles, not angels, sorry, indicated by the letters W, X, Y, and Z. Okay, so because this is a parallelogram, can you see that we know that the opposite angles of a palm are equal? So W is equal to 55 degrees because of opposite angles of a palm are equal. Okay, then how would we find X from over here? So let's quickly have a look. You can see that there's a triangle and that leg is being extended. Again, exterior angles of a triangle, X is equal to 55 plus 55. So X is equal to 55 plus 55 because of exterior angles of a triangle. And with geometry, the more you look at how people are doing it and you see the reasoning behind it, it's easier then to look out for those types of reasonings next time, or for those types of patterns. Okay, then if you want to do Y, can you see, I'm trying to keep all my things here, all my reasoning, can you see that those two were given as parallel, and there's your Z over there? So Y is equal to 55 degrees because of alternate angles. And which ones were parallel? AC is parallel to EG. Okay, and then X, Y, and Z. Can you see you can get it with interior angles of a triangle all adding up to 180 degrees. So let me just do another color. So Y plus Z plus W is equal to 180 degrees, and that is because of interior angles of a triangle. You can also just say angles of a triangle. I like to say interior angles of a triangle. So W we've got as 55 degrees, Z we're still working out, and Y is 55 degrees plus Z is equal to 180, thus Z is equal to 70 degrees. Okay, it looks like a lot and for lots of marks, but as long as you know your properties, you could have done that. Okay, then a bit of a different one. So use the Cartesian plane provided below and follow the instructions that follow. Plot the following coordinates listed below on the Cartesian plane. And can you believe some students still struggle with plotting? Come people. So 3, X value is 3, Y value is 6. So 3, I'm not going to make a cross there. Lots of you do this, 3, 6. Okay, please, please, please. It's where the 3 and the 6 come together. So 3 and 6, that's where you make your cross. 2 and 2, 7 and 2, and 6 and 6. And then they also say, and join the coordinates to form a quadrilateral as so. And it's called a B, C, and D. Okay, and what quadrilateral is that? It's a trapezium. The only quad with only one property. Name one property of this quadrilateral, and the one that we know is that one pair of opposite angles are parallel. Okay, now they say to you, if the interior angles, the interior angle of A, B, C, and D are the following, calculate the value of x. So the one thing that we wanted to test here, or I wanted to test, is that you know that the interior angles of any quadrilateral adds up to 360 degrees. Okay, so all the interior angles there. So if you have 4x plus 60 plus 2x minus 60 plus 6x plus 60 plus a half x should add up to 360. And your reason is interior angles of a quad. Okay, so then I'm going to add all my x's. 4x plus 2x is 6, plus another 6 is 12, and that half gives you 12 and a half x. And 60 minus 60 is 0, plus 60, I'm going to subtract it already on the other side. 360 minus 60 is 300, and 300 divided by 12 and a half gives you that x is 24. Okay, and we could have added as a degree, 24 degrees, or didn't have to add it, but yeah. Okay, hope that makes sense. And then the very last question, ABCD is a square. Diagonals AC and BD intersect at E, and BE is equal to 2y minus 1 as indicated, and EC is y plus 24. Then they say to you, calculate the value of x. So over here is your x's, and we know that all sides of a square are equal. So we can equal those two to each other. Do we only have one x then there, one variable? Yes, so we can solve it. And then all sides of a square are equal. Okay, so then I'm going to 3x minus x, and 40 minus 25 gives you x is 15. Okay, and that would be a measurement. If they didn't give it to you, you can always say x is 15 units. Okay, I just want to check. Gives you 70, and 3 times 15 plus 25 gives you 70. Okay. Calculate the value of y and give reasons for your answers. Okay, so again, also for y, you need to know with the properties of a square that the diagonals bisect and then are equal to each other. So what we need to know is the diagonals bisect the interior angles. No, that's the angles. So sorry, they have two congruent diagonals that intersect at right angles and bisect each other. Okay, so the diagonals bisect each other. So that would be equal to that would be equal to that. So again, like in A, we're going to say 2y minus 1 is equal to y plus 24 because the diagonals of a square bisect each other. Okay, so which means they are equal then in length to each other. Where they bisect, that side is equal to that side, and the same on this side. So all four diagonals inside, it's a little bit hard to explain, bisect each other. So they're all equal in length. Okay, and then we can work out y is equal to 25 units. Okay, so 2y minus y is y, 24 plus 1 gives you 25. And then lastly, determine the length of AC. AC over there. So if y is 25, so now we need to go and replace the y with 25. Plus 24 is equal to EC's length. Okay, so thus EC is equal to 49. Am I right? Yes, okay. And the reason there, sorry, would also be that the diagonals of a square bisect each other. So thus, to get AC's length, it would be double that. Okay, so to get the AC length, if that one is, 48, let me just make sure, 49, then double that because they are equal in length. Okay, so that's why we're going to times it by 2. All right, I hope that helped. Sorry for all the stuttering. I am a little bit sick, but I would just, I think you can benefit so much from looking at papers, working through papers with people, and that is why I love to put up our cycle tests that the students wrote so that you can just see different types of questions being asked and how to solve them. Okay, so I hope this helped a bit, and all the best with the rest of the year, and I'll see you in the next video. Thanks for watching. Bye.